welcome to the first video for section 5.1, functions of a random variable. We are working in this section in the situation where we have a random variable x, which is continuous and has a probability density function, little f sub x of x. And if we consider y to be a function of the random variable x, then y would also be a random variable. And y has its own PDF, which will denote f sub y of y. Now, section 5.1 teaches us two different techniques that can be used to find the distribution of y when y is a function of a random variable x. The techniques that we're going to see are the distribution function technique and the change of variable technique. This video is going to cover just the distribution function technique. So the distribution function technique is a way of finding the probability density function, little f sub y of y, when y is a function of x. This works when x is a continuous random variable. And we have y equals u of x. The way that we're going to find the probability density function of y is by first finding the cumulative distribution function of y. Which gives us the probability that y is less than or equal to little y. And then we will take the derivative of the CDF, f prime sub y of y, and this will give us the probability density function of y. So this is the basic process, and I've got two examples to illustrate it. So for the first example, x is a continuous random variable with the probability density function of x given by 3x squared for values of x in the interval from 0 to 1. And what we're going to do is we're going to find the probability density function of y, which is equal to x squared. So what we're trying to find then is f sub y of y. Now, the first thing that we're going to do is we are going to, as I said, start by finding the cumulative distribution function, which is equal to the probability that y is less than or equal to little y, which is equal to the probability y, remember, is x squared, is less than or equal to little y. Some particular value, remember the little y is a particular value. Now, in order to be able to figure this out using the cumulative distribution function for x, I'm going to isolate x. So this is equal to the probability that x is less than or equal to y to the 1/2 power. And this is our cumulative distribution function for x. Valued at y to the 1/2. Now, to find the value of this, I know to find the cumulative distribution function of x evaluated at y equals 1/2 is I am going to integrate from 0 to y to the 1/2 the PDF of x. Doing the integration, this gives me t cubed gives us y to the 3/2 power. So this is our cumulative distribution function of y. Now, to find the PDF, I need to take the derivative. Which is 3/2 y to the 1/2. And now we have our probability density function for y. One thing we need to do is make sure that we know what the support is of y. Since y is equal to x squared and x goes from 0 to 1, y is going to be contained in the interval from 0 squared to 1 squared, which means that y also has the support of 0 to 1. Okay, let's look at a second example. For example 2, we're going to let x be a continuous random variable with a probability density function f sub x of x equals 1/2 on the interval from 0 to 2, and we're going to find the PDF of y equals negative x squared. So once again, I start by finding f sub y of y. This is my cumulative probability that y is less than or equal to the specific value of little y. I'm going to write y as a function of x. So the probability that minus x squared is less than or equal to y. Now, in order to be able to work with the cumulative distribution function of x, again, I want to isolate x on one side here. To do this, I find that the probability that x is greater than or equal to the square root of minus y. Just a little algebraic manipulation. Now, in this case, to find the probability that x is greater than or equal to a particular value, I'm going to take 1 minus the probability that x is less than or equal to the square root of negative y. Remember that these two are equal, even though I've got a greater than or equal to and a less than or equal to here, because the probability that x is equal to any exact value for a continuous random variable is 0. So now, this is 1 minus cumulative distribution function of x evaluated at the square root of negative y. To find this probability, I integrate from 0 to the square root of negative y, 1/2, which is my cumulative probability density function of x. This gives me 1 minus 1/2 t, value of the square root of negative y, 0. And then again, this is 1 minus 1/2 times the square root of negative y. There's my cumulative distribution function for y. Now the next step to find the probability density function of y is to take the first derivative of the cumulative distribution function. So this gives me 1/4 times minus y to the negative 1. And again, I need to think about what the support would be for this function. Since x goes from 0 to 2, and y equals negative x squared, y is going to be an element, going to go from negative 2 squared up to negative 0 squared. So the support is from negative 4 to 0. So there are two examples working through the distribution function technique. Just to recap, We always start by writing the cumulative distribution function of y. We write it in terms of y. Then we substitute the function of y, written as x. Then we need to isolate x. So we do some algebraic manipulation to isolate x. Then we work with the cumulative distribution function of x to find the cumulative distribution function of y. And then the last step is just to take the derivative to find the PDF. Hope this gives you a good start working with the distribution function technique. There will be another video to watch on the change of variable technique. Thanks.